So in the previous video, we talked about values and variables and how variables can be changed, also known as being mutable, and values cannot be changed, also known as being immutable. But in this video, I wanted to go over the primitive data types, what they are, and essentially what they're good for. The first one I want to discuss is the byte. A byte is made of 8 bits, which range from the numbers of -128 to 127, and that's good for very small numbers. We don't use it as much anymore because our processors are so strong that it's just easy to use int for everything. But back in the day, if you wanted to save memory, this was completely and absolutely indispensable because, I mean, you save a lot of data in comparison to a short number or to an int. And even today, if you want to be extremely precise and memory efficient, you can use a byte. But in most cases, it's absolutely fine just to go to use an integer. And next up is going to be a short number, which is very similar to a byte. It's still quite small, but you can go up to 32,767 and down to -32,768. And it is of 16 bits. So a number such as 200 can be claimed as a short. And you might have noticed that I'm explicitly stating what they are in Kotlin. That is because if I wrote 200 in Kotlin or even 10 in Kotlin, it will smart cast it as an integer. And for those of you who don't know what smart casting is essentially, let's just remove this. If you write, let's say you declare a variable and you initialize it with 40,000, it will know that this variable is going to be a number, so it will either call it an int, or if it's very long, it will call it a long. And it will do that for you without you trying to define what it is. In Java, you always have to explicitly write whether it's a short, an int, a byte, a double, or a string. You always have to write that. But in Kotlin, it can smart cast it to whatever it has to be. So yeah, an int number is going to be this incredibly long number to that incredibly long number. I'm not even going to bother to try to pronounce it. It is of 32 bits, and in most cases, this will be the one you will use. But in case you need something a bit extra, you have this very long number, which is known as a long. And that is of 64 bits. And this is a huge number that I would never even dream of pronouncing. But in most cases, this will suffice for most of your projects. Sometimes you need a bigger number, but that's a completely different discussion. And also you may have noticed that you've seen these underscores here, and that's just to make things a little bit more visually appealing. So you can do that in Kotlin. It will ignore that and it will just make nice spaces for you so you can see how big the number is. So it's nice to use those underscores in these situations. Next, we've got floating numbers, which means you can add decimals. A float is good for 6 to 7 significant digits. So you can add you can create a small decimal essentially, and that is of 32 bits. And in case that's not enough and you want to be a bit more precise, you go for a double. And a double is of 64 bits, which gives you 16 to 17 significant digits, and essentially means you can just add a lot more decimal places. All right, and next up is going to be a char, and a char is essentially just a character of 16 bits. It can be a Unicode character, and sometimes it's only half a Unicode character, but all you need to know for now is that it's essentially just a character, such as the letter A, or I believe you can even insert the number 1 as a character. But let's go back to A. And next we have a Boolean, which has 2 states of being, which one is going to be false and one is going to be true. And it only takes 8 bits, and that can be very efficient for control flow statements. And it's straightforward, it's just as it sounds. And finally, we have a string, which is just a concatenation of characters, and that allows you to create sentences, and is great and is pretty useful for many purposes. But those are the basic types I wanted to go over. These are just good to know. You do not need to memorize these numbers, although it could help in the near future if you want to be very precise with your calculations and your codes. I'm sure there are programmers that will just love you if you pick the correct data type for the right number. But otherwise, int in most cases will just be fine. We're in a very powerful day and age where you can just use int for most things and it won't really affect the performance of your app, unless you have trillions upon trillions of numbers, of course. But in most cases, int should just be fine. And with that being said, I will see you in the next video.